Hey everyone, welcome to another session of CeerazzleDazzle Physics. In today's session, we're going to be talking about the principle of moments. So let's start off with the following. Look at this diagram here. Why is this seesaw balanced? What is the reason why the seesaw is balanced? It's because it must have the same amount of moments on both sides. So this fire extinguisher is going to be trying to spin the beam this way. Yeah? And the other extinguisher is trying to spin the beam in the opposite way. So, what do we notice? The moments from both of them must be equal. So this clockwise moment from here, this clockwise moment, must be equal to the anti-clockwise moment over here. Yeah? So both the moments must be the same on both sides. And to work out the moment of a force, we looked at this formula last time. The moment of the force is equal to the force multiplied by the distance. Okay. But let's look at a couple of examples to get our head around the actual formula. So, what is the principle of moments? It is simply this. The sum of the anti-clockwise moments must be equal to the sum of the clockwise moments. So if you were to total up the amount of anti-clockwise moments, that should be equal to the total amount of clockwise moments for the beam to be balanced. So let's look at this example. Let's check if this beam is balanced. So right now, we've got this scenario. We've got a fire extinguisher on one side and we've got a bin on the other. So let's label the distances from the pivot. Notice the pivot point is still over here. Now, we're going to do this. Let's calculate which one, first of all, let's identify which one is the clockwise moment and which one is the anti-clockwise moment. So this one, the bin, this one's going to be a clockwise moment because it will try and spin the beam in the clockwise direction. This one is an anti-clockwise moment, which will try and spin the beam in the opposite direction. So let's look at what is the sum of the clockwise moments. So let's do the clockwise moments. Which one is clockwise? It's the bin. So to work it out, I need force times by the distance. So the moment of the bin on this side here. And the anti-clockwise moment is the moment of the extinguisher. I'll put extinguisher here. So to calculate the moment of the bin, I need the force of times by the distance. And to calculate the moment of the other one, the extinguisher, it's going to be the force times by the distance. So let's work out the force of the bin. That's going to be 10 newtons. The distance to the pivot is, have a look, it's 1 meter. And now the other one, let's go, the force is 5 newtons and the distance is 2 meters. What do you notice? 10 newtons on one side. The other one is also 10 newtons. So therefore, they have the same amount of clockwise moments as anti-clockwise moments. Therefore, the beam is balanced. So if you find that the total amount of clockwise moments is equal to the total amount of anti-clockwise moments, the beam will remain balanced. And look, we've now proved it, and this is the reason why. Therefore, the seesaw is balanced. The seesaw is balanced. Wonderful stuff. Let's look at another one, a little bit harder. So, test your understanding. Will this seesaw be balanced? If not, why not? So we've got now 3 bricks on this seesaw. Let's first of all, step number 1, identify which ones are clockwise and which ones are anti-clockwise. So this one is a clockwise moment. This one is a clockwise moment as well. They'll both try and spin the beam clockwise separately. This one is anti-clockwise. Okay, so let's do it step by step. So which ones are the clockwise moments? So we've got this one. Let's work out the distance to the pivot. This is 1 meter. The other one, distance to the pivot, this one is 2 meters. Yeah? This set of bricks on this side over here, this one's going to be 1 meter. So now we have the forces and we have the distances. So the total amount of clockwise moments, so let's do the far end, it's 2 meters. So we're doing this one, 2 meters times by 5 newtons. Yeah, I'm doing this one first. So that's 2 meters from the pivot point, 5 newtons down. And that will add the other moment, which is 5 times by 1. Yeah, so this is this one over here. And on the opposite side of the equation, we've got anti-clockwise, 10 newtons times by 1 meter. Therefore 10 Newton meters on this side will be equal to 10 Newton meter here plus 5 Newton meter there. So what happens? Look carefully now. We've got 15 Newton meter on one side and 10 Newton meter on the other. Which one is stronger, clockwise or anti-clockwise? It's going to be the clockwise moment. So these ones are going to be stronger. How much? So the resultant moment, the overall moment acting, will be 15 Newton meter minus 10 Newton meter. So the resultant, the overall moment of the whole thing is going to be equal to 5 Newton meter clockwise. Yeah, let's put that down, clockwise. So we have now solved this problem. That whole problem at the start is quite difficult. You break it down, you just plug it into the equation. Total amount of anti-clockwise moment should be equal to the total amount of clockwise moment. Add them together and then find the resultant. So this whole thing, this beam, it's not going to be balanced if I remove the supports. What will happen is it will rotate. So let's check our answers. So before it looked like that. If I remove the supports, it will rotate in the clockwise direction. So we're right. Okay, so we have done this one. This is a nice problem. Make sure we can do that in the exams. And scrolling down for the summary. So the principle of moment states that for a seesaw to be balanced, the sum of the anti-clockwise moments must be equal to the sum of the clockwise moments. That statement is true. And we have the following nice thing to memorize. Just a nice equal sign. Sum of the anti-clockwise moments is equal to the sum of the clockwise moments. And that's it, guys. I'll see you next time for more CeerazzleDazzle physics. Goodbye.